If you say diving beetles, most people will picture a pond or lake. It's a reasonable assumption, and for most of the 4,000 odd species of dytiscids, it's true. It fails completely for the beetles we are interested in, though. These diving beetles spend their entire lives in less water than you could hold in your cupped hands, 100 feet in the air, inside a plant that never touches the ground. These are canopy diving beetles. So what does a canopy diving beetle dive into? The water belongs to a bromeliad. Bromeliads are plants in the pineapple family, and many are rooted to the bark of host trees rather than the soil. They have no access to groundwater, and one large group of bromeliads' solution to that shortage of water was to turn themselves into containers. Their leaves overlap at the base into a sealed rosette, and the rosette catches rainwater. These are the tank bromeliads. A single plant can hold anywhere from a few drops to several liters of water. Across a rainforest, a large amount of all standing water in the landscape is held inside these bromeliads. The tree canopy carries its own water, split into thousands of small vessels suspended in the branches, and the bromeliads are inhabited. Researchers who collected 63 of these bromeliads in Ecuador pulled more than 7,500 invertebrates from inside them, representing at least 300 different species. These are little sky ponds, and the diving beetles have colonized them. So which of the diving beetles made the move into the tree canopy? These diving beetles belong to the genus Copilotus. Copilotus is a very large group with almost 500 known species. Most of them are not canopy beetles. The typical Copilotus can be found in your local pond or lake. They are also big fans of temporary pools, which may explain why they moved to the inside of bromeliads so easily. A tank bromeliad is a small, temporary body of standing water. The fact that it's suspended hundreds of feet in the air is largely irrelevant. And from looking at the genetics of these tank bromeliad beetles, Copilotus species appear to have colonized the canopy multiple times. One estimate puts the first migration of these beetles into the trees almost 23 million years ago, close to the time that the first tank bromeliad showed up. So these beetle species may be as old as the plant containers they occupy. For roughly the entire history of water held in bromeliad rosettes, Copilotus beetles have been living in them. So what does 20 million years swimming in the leaves instead of a pond do to a diving beetle? A normal diving beetle is a smooth oval for low drag when it swims across open water. The Copilotus beetles who live in bromeliads have modified that body shape. They have a strongly convex, teardrop-shaped body. The shape is no longer optimized for crossing open water. Instead, it suits a beetle that wedges itself into a narrow, leaf-walled pocket where there is no open water to cross in the first place. Copilotus beetles have abandoned open water more than once, and in more than one way. The cave-living species of Copilotus from Brazil also broke from the standard oval shape, becoming dorsiventrally flattened rather than compactly round. The same starting body shape, pushed out of the open water, took opposite directions to a solution. So how many of these beetles are there in the bromeliads? Within the bromeliad living Copilotus lineages, populations in the Atlantic forest of southern Brazil, the mountains of northern Venezuela, and Trinidad were separated by 8% of their mitochondrial DNA. A genetic gap that size marks groups long out of contact, and it implies that unnamed diversity is hiding in the bromeliads, and the diversity that we do know of is probably miscounted. A group of insects, dispersed across thousands of disconnected pools high in the canopy, collected only by whoever is prepared to climb up there, is unlikely going to ever be counted correctly.